Welcome. We are excited that you want to learn Docker. Thank you for joining me. My name is Ram and today we are going to discuss about Docker introduction and Docker overview. We will be learning about all about the learning on the Docker. So this would be today's agenda. We will be going through the Docker overview and what is the difference between the Docker and the virtual machines, how the Docker architecture works, what is the Docker architecture. Next we will be discussing about the supported OS platforms by the Docker. Next we will be talking about the monolithic app and the microservices. So what is the monolithic app and how it works, how the microservices works and what is that. Further we will be discussing about the installation of the Docker on Linux server, and further is the next day agenda and all that. Okay, let's get started on the Docker overview. Okay, so when we talk about the Docker, so first questions come in our mind is what is Docker, right? Docker is an open platform for developing, shipping and the running applications, right? So Docker enable us to separate our application from our infrastructure, so we can deliver software quickly. With Docker we can manage our infrastructure in the same way as we manage our application in the traditional, but with the little bit differences, right? Docker provide us the ability to package and run an application in a loosely isolated environment that is called as a container. The isolation and security allow us to run as many containers simultaneously on a given host. Okay, so this is just we can say as a definitions, right, of the Docker. So what is the Docker, right? So Docker is just like the on a Linux, it's just a separate process, isolated process running on that. So as we talk about, right, so it's just a platform for developing, shipping and running applications. Okay, let's further talk on the then why we need the container, right? When our applications is already running on the server, virtual machines, just like the virtual servers, right? Then what is the need of containers? So when we talk about the standalone server, right? So in a traditional IT infrastructure, what we had a server which had the resources just like the CPU, memory, disk and all the hardware, and underneath that we had a host OS, right? Just like on one of the hardware server we have installed the operating system on that, whether it is Windows server or Linux server, and on that we are going to install an application and we are accessing that application. So that was in the traditional IT infrastructure, we were using that kind of the architecture. And further as the time changed, right, so the virtualizations comes, so the VMware and Oracle, so all these virtualization technology come, hypervisor, right? So further what they have divided and they have virtualized we can say that their hardware, right? So what they did, then they have a server, right? Hardware server which has the CPU, memory, disk and all that, and on top of that we have a software called hypervisor which provide the hardware virtualization. It's separate the resources on the hardware, right? Then what we create a virtual machines like VM, right? Guest OS. So this would be a separate instance running of the server, just like on the single hardware we are running multiple operating system, and on that multiple operating system, on the single operating system, just like the app A, app B and all their binaries, and we are using this type of the infrastructure we were using, right? So when we talk about this virtualization, so it virtualized the hardware, just like they had divided their resources based on the hardware, just like we had multiple operating system, guest operating system on a single hardware, right? But in the latest days and the modern era, the Docker, right? Docker and Kubernetes comes in the pictures, and they further virtualize their host OS, right? So they in the virtualization, what they did, separated, right, or they virtualize the hardware, but here the Docker comes in the pictures and they have virtualized their operating system. What they only we have the underneath of that we have the hardware, on that we have installed the OS, and on top of that what we did the docker engine installation, right? So that is managing everything. And then what we are doing, we are running the container, right? So container is just a running instance on application. That is all about the container. So container is nothing specific, just like the, let's suppose application running on your server, so that same application running through the container on the Docker, right? So that is called a running instance of the application, is called as a container. So simply what it is doing, it is sharing their binaries and require all the things from a single host. We are not going to install multiple OS on the container environment. We are single host, single hardware, and on top of that we have installed the Docker engine, and this Docker engine is managing everything on the instances of the application A, B and C, just like the VR multiple. So this is all about the, so when we talk about the container and VMs, right, so main difference is between the performance. Let's suppose if we are going to create a VM and we are going to install the OS, it takes a lot of time. Then we are going to install an application and it is running, right? So it takes a lot of time. But when we talk about the containers, what we have the image, we bring the image or we pull the image on the system and we just start running a containers. It's with the friction of the second, our application will be up and running. We don't need to install any further OS, right? We don't need any specific binary. So all that would be packaged into single image, right? Docker image. So that is just like we can say application package. So, and within the friction of second, you can bring up your application. So that's all about the container and the VMs, virtual machines. Further, let's talk about Docker architecture, how the Docker actually works, right? So in the Dockers, there are two parts. One is Docker client and second is a Docker host, right? Or we can Docker server. So what client does is, the client functionality is the executing command. Let's suppose we have something just like we have to run the Docker pull command, right? So we execute that command through the client, Docker client. And what this Docker client do, when you execute the command, this Docker make a request or interaction with the Docker daemon, right? Docker API. And this Docker API and a Docker daemon will look and manage everything, right? It has all the knowledge that where my applications, where my images are stored, and what container are running, and which container we have to delete when you hit the command. So all the managing of the containerization applications will be done by the Docker daemon, and from the client we are just executing the commands, we are giving the commands. Registry is a place where we are putting our images. That is just like the Docker Hub or any other registry you can use also. So registry is just a place where we put something, right? So that's all about the registry. So let me come to the one of the Linux server I have, and we will be seeing that how the, let's suppose if I have installed the Docker on this, I will show you that how the Docker client, and as we execute this command docker info, right, this docker info, then it will give us the two different information. It's give the client information, context default, debug mode false, and this is the Docker plugin and Docker versions by default we have installed. Further we come to the server, right? So it's give us the detail of the container, how many running containers are there. So all the details is with respect to the Docker daemon comes with the, or the works with the Docker daemon or the Docker server, right? So it gives a lot of detail to us, just like containers, running, pause, stop, images, all these details. So this is the architecture about the this is the architecture about the Docker, and how this Docker architecture and Docker and client and Docker daemons works. So if you want to see what is the service, right? So systemctl status Docker, this is the this is the service running on this, which is responsible for the managing all this. So Docker service, this Docker application container image, and it is up and running. Further, as I promised you in the agenda that we are going to discuss about the Docker supported OS platform. So we should have the knowledge that on which OS the Docker is being supported. Also Docker support on the two type of just like the operating system, one of the desktop operating system and one of the server side operating system. So when we talk about the desktop, then it supports on Docker desktop for Linux, Docker desktop for Mac OS, and Docker desktop for Windows. But most of the time we will not using on the desktop, so we are going to work on the most of the time on the server. So we are talking about the servers only. So on the server OS, it support the CentOS, Debian, Fedora, Raspbian, RHEL, SUSE Linux, Enterprise Server, and Ubuntu, and Binary. All this available with there are architectures just like x86, 64, ARM64, and all that. So this is all about the Docker supported OS platform. Further, as I talk about the monolithic application versus microservice application, so just think that in a traditional environment or the infrastructure, right, IT infrastructure, so what happens that they were using a application architecture that is called as monolithic, and in that monolithic architecture, what happened that all the component of the applications, let's suppose we have a web application, right, which has the multiple, just like the service which is responsible for the like, comment, and share. One is for the review, or just like the one is for the payment gateway, one is for user interface, right? So there are different and all were coupled into a single package. It was not just like the, let's suppose we have database, so all are a single bundle, right? And let's suppose we have to do some maintenance on one part of the, let's suppose my payment gateway is not working, but other all application component is working, right? And we don't want to change anything, but definitely what we had to do shutdown of the application completely. We had to shut down the application, and we need to secure the downtime for the application, right? So all the, let's suppose Amazon Web Service is the one of the web application, right? So the whole website will be down. But in the microservice architecture, what happened, all the components, right, they have loosely coupled, they are different, they are not tightly coupled with each other, right? So let's suppose my payment gateway is not working, their database is crashing or something happening, right? But so that time what happened that we can take management or the maintenance of the database with respect to the payment gateway or their payment services only. The whole application will not go down, it will be working, but only the payment will be not able to make a payment and receive payment only. So this is the architecture, just like we are breaking the application into single small parts, right? And then we are integrating that all component into a single application. But in the monolithic application, we have to do everything into a single application. We are write a large program, just like the, let's suppose in the traditional IT infrastructure development of the application, what we had, let's suppose we have using the one of the programming language, just like the C++ or Python or anything, Node.js, or right, then what we had to write everything into single. But in the microservice architecture, what we can create our application as we want, right, which is compatible for our best fit for our application development. Let's suppose we have developed user interface into Python, right? Here we can use our different database, here we can use different database, and here we can use different database. Here I can write into Node.js, I can write this application in the Perl. So that all loosely coupled, right? I don't have any dependency on the specific part, right? So that is all about the monolithic and microservice architectures. So let's talk about the installation of Docker on Linux server. So let's get on the live server. So we will be doing on the one of the server as I told you. So what you have to do, just like the right now I have the Docker, but I'm going to remove the Docker. So what you have to do, you just have to go to the Google once, so it will be easy for you. Okay, let me go to the Google, and you have to write Docker installation, right? Okay, Docker engine installation, and you have to come with the docs.docker.com, and here if you will see in the left and right install, so it's give us the overview and the installation instruction for the different OSs. Like if you have the CentOS, then you can go with the CentOS, Debian, Fedora, RHEL. I have using the RHEL, then I will be going with this instruction that how it is going to do. So what you have to do, uninstall old version, right? If you have already installed some of the versions on that, right? So before that, let's get on the prerequisites. So to get started with Docker engine installation on RHEL, make sure we meet the prerequisites. So to install, so what are the prerequisites? We currently only provide package for RHEL S369 IBM. Other architectures are not yet supported for, but you may able to install the CentOS package on RHEL, right? So this, but you can go with the CentOS if you are going to do with OS requirement, right? So RHEL 7, 8, and but yeah, definitely they are on this architecture. The overlay to storage driver is recommended. We will be discussing about this later on, that what is overlay and the storage drivers. Okay, so let's start to uninstall old version. So already, as I told you, that I have already Docker installation. So what you have to, you copy and execute this command. No package found. Okay, already let me do, because install from the package, and I have already done installation, right? So remove, but because this is latest version, right, that is why it is saying that you don't have the old version, right? Okay, so right now you can execute that same command, right, as executed, to see whether we have any other commands or other version on that. But yeah, definitely we don't have any older version, right? So it is not going to. Next, further what we have to do, we have to add this setup repository. We are going to set up a repository. You have to copy this commands and execute these commands simply. So it will automatically do all the things. They saying that adding repo from this. So you can verify yum repo list. So it will give us, yeah, definitely it had already added the repository, and we can now access the required the packages from the Docker. So to install the Docker, what you have to yum install docker c, and the all this required the container d and docker d. Sorry, it is not been copied. Okay, it is copied, and let it run. So okay, what happened? Okay, let's etc reddit release. Failed to status docker c, error during downloading metadata for repository. Okay, we have to execute a command, just like, let me download metadata for repository, cannot download that. Reboot, let me reboot the server once, and let's see if we are able to do or not, because I was having the same, because this is not the x86 based server, so it is x86 based server, so that is why maybe it is giving us a problem, right? But it will definitely work, no issue on that. Let's wait for some time. Okay, we have okay, but no issue. If we are facing some kind of the issue on that, so we will be not going to working on that. But yeah, definitely you can go with this instruction, and it will work with you. So that's all about the today's working on that. So all that, and for tomorrow, if we will come with the next video, then we will be discussing about emails, container, registry, Docker Hub, and many more things on that, how it is working. So hope you enjoyed this video. Thank you for joining me. And if you are new to my channel, please subscribe my channel so you can get